Alright, so today, this next lesson, we're looking at what's known as the scalar product of vectors. Sometimes you'll see it called the dot product of vectors. And so by definition, the scalar or dot product of vectors is equal to the product of the magnitudes of the vectors and the cosine of the angle in between them. Alright, so magnitudes of each of the vectors and cosine of the angle in between them, and the angle's measured when you put the two tails together, as you can see there. So it's written as A dot B, so that's where the dot product bit comes into it, and the scalar part comes into it in that it doesn't have a direction, it just has a number associated with it. Alright, so scalar or dot product. A dot B equals the magnitude of A times the magnitude of B times cos of the angle between. Alright, so let's have a look at an example. One that's not too tricky to start off with. Here we go. So we're told we've got a couple of vectors. A magnitude of A is 4, magnitude of B is 5, and the angle between is 30. So as we've just learned, A dot B is the magnitude of A times the magnitude of B. Straight, not curved, it's not a bracket, it's an absolute value sign. Cos of 30. So the magnitude of A is 4, magnitude of B is 5, cos 30, that's one of our first angle exact values, not one of our exact values, so we should know that. This is a triangle I use to help me remember them. So cos 30 is 30, cos is adjacent over hypotenuse, so root 3 on 2. Alright, and then 2 goes into 4 twice and into 2 once, so we now got 2 5s are 10, 10 root 3 is our dot product, scalar product, and so no units, no direction. Alright, so as we know, we could write those vectors in IJ notation, and so if we do have two vectors in the IJ notation, then A dot B is equal to x1 x2 plus y1 y2. So if I was to do that and say I've got my vectors x1 I plus y1 j dot product with x2 I plus y2 j, and then I did that dot product, then what I would have is these two together, x1 x2, and then cos of the angle between the I components. Now I is pointing in the same direction, so that's cos 0, which of course is 1. Alright, and so that's where the x1 x2 bit comes from. And then if I was to do x1i y2 j, then what you have there is x1 y2 times cos of the angle between I and j. Now by definition I and j are at 90 degrees to each other, so that's cos 90, which of course is 0, so that bit cancels out, and it's the same if I was to multiply those two, but of course the j's there and there, the y2j and that 1j, y2j, that's where the second part gets in. So that's a quick explanation about where those things, how we get this x1, x2. All right, so now we've got two ways that we can work out the scalar or the dot product using the definition above or using the algebraic method. All right, so let's have a look. Here's a couple of questions, or a question I should say. All right, so given this information, if we were to use the original definition, we'd need to find out what the angle is between those, and of course that might be a little bit time consuming to do that. So because we've got the algebraic method, we can say then that A dot B is simply 2i minus 3j dot product with I minus 4j. And as we've seen, all we need to worry about is the I components, 2 times 1, because there's one I there, plus negative 3 times negative 4. So 2 1s are 2, negative 3 times negative 4 is plus 12, and so in this case A dot B is 14. All right, so two methods that we can use to work out the dot product. We can use the algebraic, which is what I've just done there, or we can use the original definition that we worked with. All right, so with those two things there, they can be useful to us because, as I said, it might be time-consuming, tricky to work out the angle between vectors. But if you use those two things that we've got, we can work out the angle between the vectors a lot more simply than we could if we were doing it some other way. All right, so angle between vectors, so we know that A dot B is the magnitude of A times the magnitude of B because of the angle between them. And also, the algebraic form, we know that A dot B is x1, x2 plus y1, y2. So if they're both the dot product, then these two expressions then must be equal to each other, and so that's what I've got there. And so now if we just divide both sides by the magnitude of A and the magnitude of B, you get your angle. So another way we could write that, of course, is cos theta is A dot B over the magnitude of A times the magnitude of B. All right, and so by that, doing that, we can find the angle between vectors. So let's have a look. So find the angle in degrees between the vectors. Okay, so we've got these vectors in IJ form. So our A dot B part, we get from doing the dot product of those two vectors in the algebraic form. All right, so 2 times negative 1 plus 3 times 1, negative 2 plus 3 is 1 in this case. All right, what else do we need? Well, let's look back up here. What do we need? So we need A dot B, we've got that. We need the magnitudes of each of those vectors. All right, so magnitude of A is the square root of the x component square, don't need to write x, the I component, 2 squared, plus 3 squared, don't know why I put a bracket there, it's unnecessary, 4 plus 9, which I believe 4 plus 9 would be 13. All right, and the magnitude of B, we need that. That's the square root of negative 1 squared. I'll put that in brackets to remind us we're multiplying negative 1 by itself, which of course is 1, so root 2. All right then, so let's have a look. What have we got? Well, we know that the cos of our angle is A dot B over magnitude of A times the magnitude of B. And so we've got that information. Whoops. There, it's better. All right, so that then is 1 over square root 13 times square root 2, which of course is 1 over square root 26. No, didn't leave enough room for myself, did I? All right, now we get our trusty calculator out. And here it is. And our trusty calculator. Oof, been doing some stuff. Let's get rid of that so we're not. Let's just clear all the variables just to make sure. All right. So the angle cos minus 1, keyboard, there it is, cos minus 1 trig, cos minus 1 of, which is, oops, 1 over square root 26. Asked us to have it in degrees, I believe. So let's make sure I got degrees. And away we go. No, standard, I need decimal, thank you. There it is, 78.69 degrees. Right, so our angle, 78.69 degrees. All right, so there is how we would find angle between two vectors. Okay, there are other ways, but the other ways are more time consuming than the way what I've just done. All right, so that's the simplest way. All right, let's have a look. What do we got here? So example ABC are points defined by position vectors A, B and C, where, and there's our A, our B and our C. All right, so first of all, I'm going to need, I need to draw this. Some people might try and do it without drawing it. Me, I don't think that's a good idea. All right, so what do we got? Going up 1, 2, 3 here. Let's go 1, 2, 3 here. Let's go down 3. All right, point vector A is I plus 3j. All right, I'm just going to draw these vectors in some colours. So this is vector A, I plus 3j. That's there. So here we go. That's our vector A. All right. Vector B is 2i plus j. So there we go, vector B. And the third vector, let's go green on that, is 2i. Oh, no, it's not. I'm looking at the wrong one there. I minus 2j. All right, so I minus 2j. I minus 2j. There it is down there. There's vector C. All right, now the question is wanting the angle ABC. All right, so remember that these vectors that I was doing, that's point A, that's point B, that's point C. So angle A to B to C. So we're looking for this angle in here. All right, so if we're looking for this angle here, and we're looking at vectors, so we're looking at the angle between vectors. So the previous example that I just showed you, that's what we're doing. However, remember what I said right up the top was the angle between the vectors is their tails. So if it's this angle here, it's the vector BA that I'm interested in. So vector BA is what I'm interested in. And BA is negative B plus A. So A plus or A minus B. Now when we do A minus B, we've got 1 minus 2, so that's negative I. And 3 minus 1, 2J. Alright, so then the next vector then, because that's the tail, that's pointing here. So the other vector we're looking at is B to C. Alright, and so you'll notice the angle we're going to do is the first the point. And so B to C, again, it's negative B plus C, so C minus B. Let me just get rid of that one there. And put the minus sign in there. Alright. Alright, so C minus B, so 1 minus 2, so that's negative I. 1 minus minus 2, so that's plus 1 plus 2 is 3J. And so there's our vectors. Actually, I've just made a mistake there, haven't I? I've subtracted C, I haven't subtracted B. Rookie mistake. C minus B, so it's minus 2, minus 1, minus 2, minus another 1 is minus 3, isn't it? It's minus 3J. Alright, that's better. Alright, so what do we need? We need two things, don't we? We need the magnitudes of those. So the cos of angle ABC is the one we're after. It's going to be the dot product of BA and BC over the magnitudes of those. Yep. All right, so let's, I'm just going to put those down in here. Okay. So, B dot A, BA dot BC. So we got our negative 1 times our negative 1 plus the J's 2 times negative 3 over the magnitude. So the magnitude of that one is negative 1 squared plus 2 squared. And the magnitude of BC is negative 1 squared plus negative 3 squared. All right. So what do we got here then? Negative 1 times negative 1 is positive 1. 2 times negative 3 is negative 6. Down here we've got root 1 plus 4, root 5, 1, 9, root 10. And so we've got negative 5 on root 50. All right. So negative 5 on root 50. All right. So then we can go to our trusty calculator. We could try and do it by hand if you wanted to. Hey, let's do it by hand, shall we? Because (25 times 2), so 5 root 2. 5's cancel. Negative 1 on root 2. Now, of course, when we rationalise the denominator, we get negative root 2 on 2. Now, when we go back to our triangle, not our triangle, our unit circle, we're talking about cos of angle ABC. and cos is negative in the second and the fourth, but we don't need to worry about the fourth in this case. All right, we just need to worry about that angle there, the positive direction angle, all right, between these vectors, because if we go back to our sketch, all right, it's a big wide angle, isn't it, in the way it looks in the sketch. All right, so we're after that big angle in there. Now, root 2 on 2 relates to pi on 4, so that's pi on 4 in there. So cos of, oops, don't need the cos of that. I just need the angle. Then angle ABC is not quite to pi, it's 3/4 of the way. So angle ABC in that case is 3 pi on 4. Alrighty. So there's a couple of questions finding angles between vectors. Also the definition of the dot product or scalar product of vectors. So if there's anything there that you're not sure of, you need clarifying, make sure you get some help on it. And as always, have fun.